This is lesson 57 from Saxon Algebra 1. In this lesson, we're talking about adding algebraic expressions with negative exponents. So in the past, we've learned to simplify algebraic expressions by adding like terms and adding abstract fractions by finding common denominators. The common denominators in the two terms that you see here, listed on the left side of the equation, are the first denominator is x squared y, the second is x cubed n squared. But we want to find a common denominator for the two terms. And the common denominator would be x cubed m squared y, because we want to look at both of these and make sure we're accounting for every variable in there, and then also accounting for it the most time it appears anywhere. So for our x's, because they both have an x, one is an x squared and one is an x cubed, because we have to do the number of times of the greatest one, that's why we have x cubed here, because of the x cubed. We need to make sure all our x's are accounted for. And then with our m's, because we have an m squared here, even though there are no m's in the other one, we need to account for every single variable. And then our y's just remain one y because of the y in the first term. So again, that was similar to the lesson where we were talking about the least common multiple. When you're using numbers, you break it down into prime numbers and make sure to include the most of each one. So it's the same thing with the variables. So I'm going to clean this up a little bit and rewrite that common denominator, because I want to show you how they got the expression on the right. So we decided that x cubed m squared y is the common denominator for these two terms. So in order to add those two expressions, we need for them, again, to both have the same denominator. But to now decide how the numerator changes, we need to figure out, to get from our original denominator to our new denominator, what did we need to multiply the x squared y by? What did we multiply that by to get that new denominator? So there were already two x's, and it turns out we need three x's. So we need just one more x. And then looking here, we don't have any m's in that first term. So to turn it into the second term, we need to account for two more m's here. I didn't leave myself much room. I'm going to spread this out a little bit so I have a little more room. And then, I didn't have to create that much room, because it looks like, looking at my y's, I had a y and I end up with a single y. So really all I'm multiplying by my first term is a new xm squared. So that is what I'm using to multiply by my original numerator to get my new numerator right here. So when I multiply the a times the xm squared, I can just write it like that. Then I'm going to erase what I have below so you can see me work with the next term. So now I need to turn this b into a new numerator right here. So I need to figure out how this denominator changed to my new common denominator. So I'm going to write the original denominator of x cubed m squared and think, what did I need to multiply that by to get this new numerator? So I had three x's and I have 3 x's here. So the x's don't need to multiply by anything because they don't change. Then as you can see, the m's started with an m squared and end up with an m squared, so those don't need to multiply by anything else. But I don't have any y's here, and I end up with a y, so that means I needed to multiply it by a y to get that new denominator. So that's what I'm going to multiply this original numerator by to get my new numerator here. So I had a b, and I just need to multiply that by a y. So when I add the two numerator terms together, I'm just going to rewrite axm squared, add it to my by, and I can write it, because these are common denominators, I can write them both over this same denominator. So that was all to explain how they turned this fraction into this. So now we're asked to simplify a different algebraic expression. And that expression is ax to the negative first power plus y to the negative first power. Now when you look at this, the method of attack is not immediately apparent. What we want to do first when we have negative exponents is to first write the answer with all positive exponents. So we need to move those exponents into the denominator if they're starting in the numerator like they are here, or if they started in the denominator, we'd move them into the numerator. So I'm just going to rewrite this with the variables that don't have a negative exponent, keeping that in the numerator. But I'm going to rewrite the variable with the negative exponent in the denominator. I can change that -1 exponent into a +1 exponent by putting it in the denominator. But because when we have a +1 exponent, it's always assumed, so we don't actually need to rewrite that. Then for our second term, there's no other variable but the y, but I need to put that y in the denominator. Again, I'm not going to write the +1 exponent. I'm just going to remember that it's there. And because now we have no numerator, I need to put the 1 there just to represent and hold that place so we don't forget that there's not just a 0 or no numerator there. So now that we have it written in this form, we are going to do the same thing we did before and decide on a common denominator. So because we're only dealing with 2 variables already, it makes it a little more straightforward than the last example problem. So the common denominator for x and y, we need to include an x and we need to include a y so that both variables are accounted for. Then we need to decide what to put in the numerator of the first one. We need to multiply this numerator by whatever we needed to multiply the x by to get the new denominator. So x needed to multiply by a y to become xy. So I am going to multiply that a by a y as well. Then for the second one, I'm going to look at y and think, what did that need to multiply to become xy? It needed to multiply by an x. So that's what I'm going to multiply my 1 by to get my new numerator here. So that's how I made all the decisions for how I transformed those fractions. Now that we have that common denominator, I can rewrite the denominator as just a single xy, and now add the 2 terms up top. We have an ay and an x. And that's as simplified as we can make that expression. So again, it started out right here where it was pretty unapparent of where to begin. But the best place to start is to turn your negative exponents into positive exponents and then add, and then go through the steps you need to that help you add them together with common denominators.